Hello, my name is LeeKokThye, and this presentation explains my database management system designed for an autonomous vehicle fleet operator. By the way, I'll be using the word AV a lot, which stands for autonomous vehicle. So this project focuses on how a database management system can manage complex AV data such as vehicle records, trip, telemetry, safety incidents, software version, and maintenance across multiple cities, while supporting analytics and decision making. So to begin, I'll briefly explain what a database management system is and why businesses rely on it. So a database management system is basically a software that stores and manages data in a structured way. Instead of having many Excel files, text files, or separate systems within a multiple business function, a database management system keeps everything together in an organized tables with rules and constraints to ensure data integrity. So one of the examples include MySQL, which is the system that I'm using for this report and presentation. In a business, a database management system is important because it keeps data accurate and reduces duplication. It controls who can view it or edit the information, basically more data security, allow fast searching and reporting, integrate data from different departments into one centralized system, and it supports analytics and decision making. For AV, the challenge is even greater. So AV companies basically collect tons of data, such as frequent trip logs, detailed safety incident records, and many more. So basically, this huge amount of data, the spreadsheet cannot manage this amount of data. They cannot guarantee relationship, enforce constraint, or support performance at this scale. So my project designed a database management system that's suitable for the AV operation. So this is the business scenario. So the scenario assumes that a company operating AV in multiple cities. So the vehicles start and complete trips, they collect sensor data, they occasionally face disengagement or safety incidents, and they require maintenance. Sometimes software is also frequently updated as well. With this much data from different sources, information might exist in isolated files. Without a database management system, trip logs might be in one spreadsheet, maintenance records might be in another, incidents document are separate from different files, and telemetry are stored somewhere else in the other database. So there's basically no unified view of the vehicle history. This leads to problems such as inconsistent records, human error in input and output of analytical reports, difficult tracing of what actually happened within the operations, no investigation when incident occurs, which limits the analytic capability of an AV company. So by introducing a database management system, everything becomes more centralized and structured. The organization gains from the database management system by having one reliable source of truth, faster incidents investigation, better monitoring of AV uptime and safety, improved compliance and audit readiness, and smoother reporting across different cities and operations, which is very essential for their operation. So next I'll be talking about what kind of data domain do AV company needs with this ERD, which stands for Entity Relationship Diagram. So the company basically collects several key data domains, which include city and depots. This records where fleets are located and managed. It helps allocate resources and compare performance by city. Next, we got vehicle, which include the model, the autonomy level, and the assigned depot of the vehicle, which allow the tracking of performance and life cycle of each vehicle. And then we also have the trips and routes, which capture the start and end time of each trip, the route used by a vehicle during a journey, the distance and status of the vehicle during a journey as well. This helps analyze service reliability and operational coverage of the AV fleet. Then we got the telemetry data, which includes the speed, braking frequency, and object detection, which is used to study the driving behavior of the vehicle and identify risky situations during a trip. And then we have the safety incident and disengagement, which store the type, severity, and the cause of the incident occur during a trip. This support investigation, audit, and safety reporting. And then we got the software releases and vehicle software, which track the version installed on each vehicle, which help compare the performance before and after the software updates and installation of each vehicle. And then we also have the maintenance order, which records parts replaced and status of the vehicle being maintained in the depots. This helps predict breakdowns and plan preventive maintenance. Each domain supports business decision, analytics, and compliance. So let's go into how data travels through the database system within the AV operation context. So when a vehicle starts a journey, a trip record is created. The database management system collects key information such as the vehicle ID, route used by vehicle, start and end time, distance travel, status of the trip, And through these relationships, the trip is automatically linked to its depot and city. While the trip is active, the AV constantly sends sensor readings from the sensor before entering the database. So basically, the data goes through the ETL pipelines. The data is extracted from the vehicle. Then the data was cleaned and standardized before it was loaded into the telemetry table. So each telemetry record references the trip ID, so the system stores the data in an organized manner. This allowed the analyst to replay events moment by moment and connect the driving behavior with the specific outcome with the specific vehicle. So if something abnormal happens during the trip, such as disengagement, a safety incident entry is created. And because it links to the same trip, manager can see what the car was doing, where it happened, under which condition, and on which software version was it installed on the vehicle. So the software release and vehicle software table shows which version is installed on which vehicle at a specific time. So this allows the company to manipulate and compare data. For example, whether a new version of software reduces the incident risk. So lastly, if the vehicle later requires repair, the maintenance order is created. So the database management system basically records information on when the vehicle went out of service, what parts were replaced during the maintenance, and when the vehicle returned to operation. Later, this data can be retrieved through SQL report to analyze reliably by managers. Because of everything is stored and connected within one unified system under one database management system, it improved the security through the control access, improved accessibility of the data so different teams can use the same trusted data. It also supports better decision making through accurate reporting and analytics. Through this relationship, manager can actually move from one table to another table and reconstruct a full operational story. So basically, this means that the manager are able to get a full picture of the operation, of what's going on within the operation currently, so they can make an informed decision. For implementation, my design used MySQL with InnoDB as its storage engine. So InnoDB supports ACID, which means atomicity, consistency, isolation, and durability, meaning the data remain reliable even during crashes and concurrent edits. So the key database management system components considered include storage engine to manage SQL data, query processes to execute SQL, transaction and concurrency control, catalog or metadata to define tables, constraint and relationship, security roles to restrict access, and backup and recovery mechanism. Then the development process of the database management system includes these 6 steps, which are requirement analysis, which involve identifying what data do the AV company needs, conceptual model, which involve building a ERD, which I have shown earlier, to see if the database management system design aligns with the business function. Then comes with the logical model, which involves the normalization of all tables within the database and the use of primary or foreign key definition. Fourth is the physical model, which involves selecting data types, indexes, and constraints. And fifth involves implementation of the database management system, which involves us creating the tables and using SQL queries to manage the database. Lastly, we have testing, which involves testing the database by running SQL queries such as insert, updates, delete, or retrieve analytical reports. And if the system runs well, the database management system can fetch you accurate reports for manager to analyze current business situation and make informed decisions. So to conclude, the AV focuses on database management system provides several key benefits. It improves data integrity by eliminating duplication and enforcing relationships. It also enhances safety analytics by linking the telemetry, trips, incident, and software versions. It supports operational uptime by monitoring maintenance frequency and availability. It also enables stronger regulatory reporting through traceable and auditable historical data across cities. The system also supports evidence-based decisions such as reducing the incidents, improving maintenance turnaround, and evaluating the impact of new software releases. Moving forward, the system can be strengthened further, so we can improve the data quality by including data validation and duplicate checks. Next, adding better indexing will help handle a large telemetry tables efficiently as well. And then by integrating dashboards like Power BI, it will support real-time monitoring instead of static reports. Finally, automating the ETL pipelines will reduce manual uploads and ensure data flows continuously into the database. That is all from me. Thank you.